So looking at the reflection rules, I'm going to construct a point A that is at 3, 2. So 3 to the right, 2 up, and that is my A. I want to label the y-axis, which is this one right here, as my line of reflection. Now, recalling the definition of a reflection, I want to say that the line of reflection is going to be the same distance between corresponding points. So this line of reflection to my A is going to be the same as that line of reflection to my A prime. So going from the line of reflection to A, I get 3 spots, 1, 2, 3. So I want to go the same number of points, 1, 2, 3 to the left, and that is going to be my A prime. So if I look at those points, this one was originally at 3, 2. If I look at that in this problem, I get a negative 3, 2. So if I look at those coordinate points, going from a 3, 2 to a negative 3, 2, the only thing that changes is the sign of my x value. So I go from my original xy to a negative x comma y. We're going to go ahead and do discovering rotations on the coordinate plane and discovering rotations without a coordinate plane in class. So let's go ahead and take a look at using the rules that we have done so far and some that we have on that first page. Let me actually show that to you again if you want to write down these rules. You can pause the video and go ahead and get those written down. So let's go ahead and get started with question number 1 here. I want to transform the given figure by the translation rule xy maps to x plus 2, y plus 4. So I'm going to take each coordinate point. My A value is at negative 4, negative 3 currently. B is at negative 3, negative 1. And C is at 0, negative 3. These are my current points. I'm going to go ahead and use the rule of x plus 2, y plus 4 to get my new coordinate points. So I'm going to take a negative 4 plus 2 is going to give me a negative 2. A negative 3 plus 4 is going to give me a positive 1. Negative 3 plus 2 is a negative 1. Negative 1 plus 4 is a positive 3. 0 plus 2 is 2. Negative 3 plus 4 is 1. So I want to go ahead and plot these points. I get a negative 2 up 1. That is now my A prime. It had been my A, so now this is going to be my A prime. My B prime is going to be at negative 1, positive 3. 1, 2, 3. And my C is going to be 2, 1, or my C prime rather, is going to be at 2, 1. Okay, and that is all I have to do for transforming a given figure by a translation. We're going to go ahead and practice more of these later. Right now I'm just going to go ahead and go over a few more examples of different types of transformations. So reflecting across the y-axis was the one that we had done earlier, where the only thing that changes from the original to the new point is that I changed the x value. So here I want to make that 0 a negative, but a negative 0 is still just a 0, so that one doesn't change. My 4, instead of being positive, I want to make it a negative. And my 3, instead of being positive, I want to make it a negative. Now, if any of these had started out being negative, then they would become positive. That negative x just means that I want to flip the sign of whatever I currently have. So I'm going to go ahead and plot those points. So 0, 5 is going to be in that same spot. Negative 4, 1, 2, 3, 4, positive 6, and negative 3, positive 3. So that is reflected across the y-axis. Now that h did not change. Going from h to h prime did not change because that point was on the line of reflection. My y-axis was the line of reflection here. So since that is what I'm reflecting over, any point on that line is not going to change. We worked with that on our Khan Academy practice too. So here, looking at our line of reflection of y equals x, the first thing that I'm going to do is graph that line y equals x, which is where all of my values of x are going to be the same as my values of y. So for example, my x is 1, my y is 1, my x is 2, my y is 2, so on and so forth. So here, in order to reflect over that line y equals x, I'm just taking my x and my y value and switching them. Now on these previous ones, you can do a lot of them just by counting. So for example, if I look at this translation, another way that I could have done this is to just count 2 to the right, 4 up. For each point, 2 to the right, 4 up. Some of these are a little bit harder. From here, from the y-axis, that's my line of reflection, I can count 4 this way and 4 that way. For each one of these points, 3 this way, 3 that way, to get my image points. But for the line y equals x, it's a little bit harder to do that because my line of reflection is at a diagonal. It's a little bit harder for our brains to kind of, to just do that by crossing over, like where exactly would I put it. So these ones are much easier when I just go ahead and use my rule to flip my y and my x. So I'm just going to go ahead and do that real quick, and we see when we do that, the k does not change because, again, it is on that line of reflection, so it isn't going to be flipped over when we reflect. K is on the line that we are reflecting over, so it's going to stay put. So 3, 3 stays 3, 3. So our h is going to become 5, 0. That's our h prime. And then 6, 1, 2, 3, 4 is going to be our j prime. And so we get the now k prime, h prime, j prime as our image. Now it's really important with these that we've done so far, I get the same image, same size, same shape from my original to my new image with a reflection. Same size, same shape, again with a reflection. same size, same shape, again with a translation this time. So just as we learned in our Khan Academy videos, if I have a translation, a reflection, or a rotation, which we're not going over in this video, but a rotation works as well, those are all isometries. They will stay the same size, same shape from the original image to the new image. So the last little bit of our notes here, I'm on the last page, page 8. We are going to reflect the given figure about the y-axis. And what do we notice? So if I look at my image over here, if I take this B would be 3 to the right. If I reflect it across the y-axis, I'm going to get 3 to the left. So that means this B prime and the C prime that was 3 to the left will now be 3 to the right. A is on the line of reflection because the y-axis is our line of reflection. So basically I'm going to get the same image again. The only difference will be that B will be on this side and C will be on that side. When that happens, when I get the same image back with that line of reflection, that is going to be a line of symmetry. So I want to say here that we get the same image this makes the y-axis our line of symmetry. Maybe I should say a line of symmetry, because there are going to be more than one sometimes. So this is at least one line of symmetry for this triangle. So let's go ahead and take a look at some of these shapes down here. The top portion of our shapes are going to be all regular polygons, and what that means is that every single one of these sides in this is going to be the same. Each one of the sides of the pentagon are going to be the same. Each one of the sides of the triangle are going to be the same, and each one of the sides of the hexagon are going to be the same. Obviously, that's not true for the rectangle. So I wanted to go ahead and start out by saying that the square has 4 sides. It is a regular polygon with 4 sides. Pretty simple. So I'm going to go ahead and take and just find my lines of symmetry. So if I cut this in half this way, I will get 2 identical images on the top and the bottom. I can do the same thing. Going this way, I would get 2 of the identical rectangles on the left and the right. I could do the same thing diagonally. Basically, if I fold this over, I will get overlapping or mirror images. This corner and that corner will line up perfectly if I fold it over that blue line I just created. So these are all going to be lines of symmetry. So I had 1 going up and down, left and right, and 2 diagonals. So that's 1, 2, 3, 4. So I had 4 sides, 4 lines of symmetry. So for they're also asking me for the angles of symmetry. I'm going to take my 360 degrees and divide it by the number of lines of symmetry. That is going to give me 90. So what that number represents is that if I turn this square 90 degrees, I will get the same square back. If I turn it another 90 degrees, I'm going to get, again, the same square, same orientation and everything. If I turn it 270 degrees, I will get the same thing, and 360. And that's all I have, all the time I have for part